All right. Hey everyone, welcome to today's webinar with Parsec, and thanks for joining us. My name is Avery. I'm on the marketing team here at Parsec, and I'm joined by Daniel from the solutions architect team, who will be leading us in a discussion on how to deploy Parsec in the cloud. If you have any questions throughout the presentation, please drop them in the Q&A button at the bottom of your screen, and we'll have some time for a dedicated Q&A session at the end. So before we get into today's topic, I want to quickly introduce Parsec for anyone that might be new. Parsec is a high-performance, low-latency remote desktop solution that allows your team to access your workstations, whether they're on-prem, virtual machines in the cloud, or a mix of both from anywhere. Parsec's business solutions offer the performance, responsiveness, and collaboration capabilities that creatives need to be able to work remotely, along with the security and the granular controls that their organizations might require. If your org is considering moving to the cloud, deploying Parsec will provide quick time to value, enabling your team to continue creating amazing work just like they have in the office. We've even partnered with a few cloud implementation and integration partners, which we'll discuss in just a bit. So Parsec can be a great fit for many different use cases and industries. And as you can see at the bottom of this slide, we've listed a couple of our customers, and our customers really range in industry. We've got a lot in game development, post-production, animation. We even have customers in architecture and ad agencies, and a lot of other industries as well. But regardless, if your team needs access to GPU-enabled hardware and software, Parsec can improve your team's remote work experience. Implementing Parsec into your organization's workflow can have tons of positive impacts on the business that can range from things like improving employee happiness and productivity to being able to access global talent. And again, if you're looking for a solution that has quick time to value, downloading Parsec for your team can be a game changer in your work from home or hybrid strategies. It takes less than 10 minutes to set up Parsec in the cloud, which can give you almost immediate access to many of the benefits of remote work. So now that we've introduced Parsec and talked about some of the general benefits of using it, let's get more specific about the benefits of using Parsec in the cloud. Working from the cloud benefits not only those in the office, but also those out of it, because you can also access your workstations and projects from anywhere. This means you can hop from conference room to conference room, you could knock out some work while you're at home, or you could even access your machine while you're traveling. The opportunities are endless. And this is especially impactful for distributed teams. Setting up cloud instances near each individual team member instead of having physical hardware in one location will ensure that everybody has that same low latency, high performance connection. And you also don't really need to worry about security with Parsec. By maintaining limited access to IP and using peer-to-peer connections, team members can work on their projects without the information ever actually leaving that host machine. Deploying Parsec in the cloud can also offer major cost reductions, as the team can be provided with much more basic hardware or thin clients that they take home with them, and then use to access those more powerful tools that are being hosted in the cloud. Additionally, it supports operating expense budgeting to pay for what's in use rather than only leveraging a fraction of the machine's power during parts of the day. Ultimately, using Parsec in the cloud can provide a consistent workspace environment for both the creative end users who need access to their powerful tools and their IT teams who can easily and securely manage and control the cloud environment. So let's talk about some of the different cloud providers that are available and how you can get Parsec up and running in the cloud. Parsec can be used with many cloud compute providers, whether it's Microsoft Azure, Amazon Web Services, Google Cloud Platform, Paperspace, Oracle, OpenStack, or one of the other many options out there. And for today, we're going to see Daniel give a step-by-step of setting up Parsec in AWS specifically. So whether your organization operates fully in the cloud or is using a mix of physical hardware and cloud machines, Parsec can be integrated to improve your remote work experience. And as you can see on this slide, we've also partnered with a few cloud providers and integration partners that can really help to make setting up Parsec in the cloud super simple. So we've partnered with both Amazon Web Services and Microsoft Azure You can visit either of their marketplaces, search Parsec, and you'll see a few options populate. You can choose between those and have a Parsec system spun up in just a few clicks. And for companies that don't want to go through that process of going to the marketplace, picking the AMI, installing the software, configuring the network, and all of that on their own, we've also partnered with Bebop Technologies and Arch Platform Technologies who can handle that process of cloud integration for you. So again, there's a lot of cloud options out there. Many of them will work with Parsec, but let's watch this demo that Daniel has put together to show us just how easy it is to spin up a Parsec instance in AWS.
Hey everyone, my name is Daniel Shields and I'm one of the Senior Solutions Architects here at Parsec. Today, we're going to be taking a look at just how easy it is to deploy Parsec in the cloud. Now, originally, I was going to try to shoot this video while riding a bike, but not exactly the safest thing to try. So instead, we're going to go get a cup of coffee, sit down on a nice park bench, and go ahead and deploy Parsec in AWS. Okay, so we have our coffee, we're all set up here at the table. Let's go ahead and deploy Parsec in AWS. Now what I'm going to do is I'm actually going to record my screen at the same time that I explain to you what's going on here on camera. So once I start that screen recording, what we're going to see here is actually our Parsec for AWS Terraform template. Now, if you've never used Terraform before, that's okay. We actually provide you some steps on how to use that within our GitHub page. So what this allows you to do is very quickly deploy Parsec without having to do a lot of architecture that you would normally have to do in AWS. So if you're not familiar with how AWS or any cloud platform works for that matter, we make it extremely straightforward in order to deploy Parsec there. Before I get started on all of that though, I do want to take a quick aside and just mention Parsec can be deployed on just about anything. So if you'd like to deploy Parsec on hardware that you have in your office, racks in your data center, a hypervisor that you already have, or any cloud platform of your choosing, as long as that machine has a GPU that we can do video encoding on, we're golden. You can deploy Parsec just about anywhere. Today though, we're going to be focused on AWS and the GitHub template that we can use to deploy Parsec quickly. Now, AWS has some prerequisites for any host that is deployed within its architecture. You have to create things like VPCs, subnets, route tables, route table associations, and a bunch of other stuff that can be kind of complex if you've never done an AWS deployment before. So our goal here today is to show you how quick and easy it can be by simply deploying using our Terraform template. This has been tested and it's been used at other customers in order to get them up and running extremely fast. If you're familiar with Terraform, a lot of this will probably be review, but if you're not, pay attention, there's a few cool things in this video. So inside of the template, we have a few things that we need to gather before we can actually get started with deploying Parsec in AWS. A few of those things are quite simple. We do need an AWS access key in order to do things in AWS on your behalf. So you'll need to gather that if you're not the administrator for your tenant. You will need to gather that information from your administrator. You'll need to pick a region where we're going to deploy these resources. In my case, I've selected CA Central 1 and CA Central 1B. I live in Toronto, so Montreal is pretty close by. And then you'll also need to specify your key pair and your Parsec for Teams config. Kind of handling those in order, your key pair is what we're going to use to decrypt the password once Parsec has been deployed. And then finally, that Teams config allows you to customize the Parsec for Teams installation during the actual install. So you don't have to do anything on the host. It'll be ready to go the moment that this Teams config string runs on the actual host. The other variables that exist here, so you can see lots of other tabs within VS Code, are completely optional. You don't have to use them. You don't have to make any changes to them if you don't want to. If you want to customize certain aspects like the hard drive size or something like that, you can do that. All the files are there. If you're familiar with Terraform, you can even import this as a module to be used with your existing Terraform infrastructure. And then the last piece that we need in order to kick this off is the download URL to our high performance relay. You'll notice there's a lot of stuff blurred out here. There is some sensitive information that I'd rather not share in webinar format. One of those being the Parsec for Teams high performance relay URL, as well as some of my configuration information. This URL is specific to your subscription for Parsec for Teams Enterprise. So this can't just be used with any Parsec deployment. You do have to have Parsec for Teams Enterprise. Once we have this URL, once we have all this information here, we're going to go ahead and prep Terraform on how to deploy Parsec in AWS. So we're going to type Terraform init in order to prepare the Terraform deployment to launch all of these instances in AWS on our behalf. We're going to type out Terraform plan to generate a list of what we're going to do in AWS. So this is kind of your opportunity to double check your homework and make sure that everything is right. We're also going to need these two outputs once they have shown up at the end of the Terraform apply process. So this is going to take a minute or two. We do have to wait for AWS to provision us resources. So what I'm going to do in the meantime, once I kick this off, I'm going to point the camera at the computer screen with a stopwatch so that you can see just how little time this actually takes. Should take around 5 to 10 minutes, but let's go ahead and kick off that process. We're going to use Terraform apply, and I'm going to use a special flag on the end of this called auto approve. And the only reason that I'm doing that is so that I don't have to type yes again once I've started the stopwatch. You may not want to use this on your first Terraform run, because instance charges will start applying the moment those resources are deployed. So I've just hit enter, Terraform has its headings, and now I'm going to start the stopwatch. So I'm going to point the camera at the computer, get a couple of drinks of coffee here, and we'll come back once our instances are up and running. Now that we're back from our coffee break, we can see that this instance is finished deploying in AWS. I've done a little bit of configuration here in the background, namely adding our high performance relay internal IP to the Parsec for Teams config page. Assuming all went well, which it probably did, I should be able to connect to this instance sitting here in Trinity Bellwoods Park. And as we can see, we see the Windows lock screen. I've connected to this instance successfully. I've not touched this instance apart from running that Terraform configuration that we saw just moments ago. So it really is that easy to get started with Parsec in AWS, or really any cloud platform for that matter. Give this template a shot. Feel free to reach out to the Parsec team. We're more than happy to help you on your work from home and cloud journeys.
Awesome. Thank you, Daniel, for putting together that demo. I'm going to pass the floor over to him now so he can answer any questions that have been submitted to the Q&A. And again, if you all have questions about things that aren't necessarily about today's topic, you just have something you want to know about your own specific workflows, please feel free to drop those in the Q&A. We have plenty of time to answer them.
Awesome. Thanks, Avery. So we did actually get a question about having the video after the fact. I'm going to leave that up to the marketing czars to distribute. Probably should have a video out at some point. I know maybe a little issues here with Zoom screen sharing. Should use Parsec for that, right? So we should be able to get that video out to you at some point after this. All right, and I'm keeping an eye on the Q&A here. Let's see. And no questions after that. Wow. Oh, here comes one. Review the architecture. Yep. So what actually gets deployed is in the actual Terraform deployment process, it creates the VPC, the route tables, the subnets, the security groups, as well as two virtual machines. It creates the high performance relay virtual machine, which is based on Ubuntu, and then it also creates a Windows Server instance that is used for the actual Parsec host. So one of the things that I will call out that's important is you can't just use a generic EC2 instance. It does have to be an instance with a GPU attached to it. So you are going to want to make sure that it is something with either like a Tesla T4. I know in AWS that's a G4DN. Or I think it does work with the G5 instances now, which are Tesla A10Gs. So as long as you have some sort of GPU based instance, that will work. And then apart from that too, inside of the actual the way that the architecture is laid out, is there's two security groups. The first is a public zone. That's where the high performance relay lives, because the idea is to kind of give a bit of separation between the actual host and the outside internet. And then the second is a private zone that gets created for just the host. And the way that the security groups are configured is the only communication that's allowed between the private zone and the public zone is going to be that high performance relay traffic. So Adrian, hopefully that answered your question. If not, yeah, put a follow up there in the Q&A and I can answer it. Does Parsec work in GCP? Yes, we do. AWS and Azure are kind of, that's where our templates are right now. So in the video, I used our AMI or AWS machine image. In Azure, we also have a marketplace offering. So if you search for Parsec in the Azure marketplace, you will see Parsec pop up there. I think it's just listed as BYOL. And then, of course, we do work on hypervisor platforms like VMware ESXi, Citrix Hypervisor, Hyper-V, Nutanix. The important part is that machine needs to have a GPU, whether that's through NVIDIA Grid or a direct attached GPU. The next question I have here, is there a required AMI for the Parsec client or can it be deployed using your own AMI? It can. So you can actually deploy Parsec on your own machine image. The way that that's done, there's two different ways you can handle that. The first is you can set up that image with the GPU, set up in the, I think it's called WDDM mode in NVIDIA language, to have a display device on that GPU. And then the second is we actually have a script called the Parsec Terraform, the Parsec Cloud Prep tool that runs a lot of the basic configuration needed on that image. And I know it works in AWS, Azure, and GCP right now. So you can create your own AMI. I have customers that do it. Again, just make sure that AMI has a GPU attached. Is there a list of VM sizes that are recommended for Parsec? That is a good question. I don't think we currently maintain a list of the VMs. I know in Azure, the one that I hear often is the NCAS T4. In AWS is the G4DN, and you can do it with a G5 in AWS. Really what you're going to want to look for is, does that VM support display modes? Does that VM have a GPU, of course? But let's see, you're asking about the AMD MI25 or the Tesla M60. I know it works with the Tesla M60. I'm not sure about the AMD MI25. So that may be worth a look. I know the Cloud Prep tool does have a specific list of GPUs that it supports, which I can actually put both of the links that I've been talking about today in the chat. So here is the actual Terraform template. So you should see that. Oh, that went out to the panelists. Avery, is there a way to send a link to the attendees? I'm not great at Zoom webinars, sorry.
I don't have an option to, but we can make sure if we send out any follow-up after, we can include those links.
So actually, hang on, I think I can put it in the answer. So I will send that as one link, and then let me attach the Parsec Cloud Prep tool. All right, so if you look at the answered question to Ross Smith's question, you should see two links in there. The first is the actual template that I used in the video, and then the second is that Parsec Cloud Prep tool. All right, the next question I have, hang on, is identity management. So we have the ability to integrate with your SAML single sign-on provider. So if you're using anything that is SAML based, it should work with Parsec. Our most popular ones like Azure AD, Okta, Duo, Google SSO. I know that those will work quite cleanly, and we actually have guides for, I believe it's Azure, Okta, and Google SSO, I think is what we have currently listed in our guides. OAuth, I'm not sure about. I assume if your OAuth provider has the ability to do SAML, then it should be able to work with Parsec. We have a guide for custom single sign-on with SAML because we have a couple of attributes that we need. But for identity management, yeah, that can be handled through your single sign-on. Oh, we got a different one. Is there a suggested workflow for generating guest invites automatically to be emailed to each of these instances? Say you want to do beta or public testing. The workflow for that would probably entail using our API. So Parsec does have an API that is a part of the Enterprise Edition. The way that it would work in the guest invite system is I assume you could bring it together in some sort of larger tool like Zapier, Retool, or Monday.com. We don't necessarily have a suggested one here at Parsec, just whatever tool you use to kind of fire off a large number of actions at once in order to generate a guest invite attached to the VM that's been created so that as soon as that VM is ready to go, which actually for the anonymous attendee who asked, I would also say use your own custom AMI so that you have the game software, whatever you're developing and beta testing ready to go. So that the moment that AMI comes up, you don't have to do anything else. Parsec's installed, it's set up, it knows exactly how to connect, so that all you have to do is then within the API, tell Parsec to generate a guest invite for that specific machine. So not necessarily a suggested workflow, that's kind of how at least I envision doing it. The right way to do it through Parsec would be through our API. It's a cool use case too. Do an autopilot on any sort of beta testing. So somebody had issues deploying on NVV4s. So with the NVIDIA or the NCAS, sorry, the NVV4 SKU, I'm not sure the details of that one specifically. If it is based on a Tesla T4, like I think it is, and I can double check here off to the side. The important part is that the machine has to be set up in a mode with a display. If it doesn't have a display or it's not set up in WDDM mode, you are going to run into some trouble just purely because at that point in time, there's nothing for Parsec to capture. Parsec does all of its magic with the frame buffer, and if there is no frame buffer, there's nothing for us to capture. So it looks like the NVV4 is AMD Radeon Instinct, MI25s. AMD is kind of hit or miss with the way that their GPUs support certain features that we require. I'd be interested to hear kind of what those specific issues were so that we can potentially work through them. I know our AMI does not use that specific instance type. I believe we use a different instance type. I would encourage you to ensure first that that is set up in a desktop mode, and then second, when you run through the cloud prep tool, go through and install your own Radeon specific drivers. I'm guessing if it's like NVIDIA, they're probably going to have a driver that is specific for gaming and then another that's specific for GPU accelerated compute workloads. Make sure that you're not using the accelerated compute one because that's not going to do anything for us. So curious about that one. Maybe we'll follow up on that later to see what's going on. All right, the next question we have, lots of good questions. We have 50 terabytes of data. What do you recommend to keep all data rapidly in sync so that users can feel like they're working locally, even with large single files? In that case, you're going to want to utilize the backplane of the cloud platform that you're in. So for Yari, who asked this question, if you have users that are distributed over a large area, it's going to be way faster to use the backplane of whatever cloud platform you're in to potentially set up VMs in regions that are closest to them. So I'll give you kind of a North American example. If you have people in San Francisco and people in New York, you could deploy resources in US West or US West 2, and then have resources in US East. And then in order to move or not necessarily move, but access the 50 terabytes of data over a long distance, you can do a lot of that by using the backplane of AWS, as opposed to going out over the open internet from site to site or from machine to machine. You could set up your own IPsec or OpenSSL VPN to move some of that traffic back and forth, but nothing's going to be faster than going from an AWS region to an AWS region if they're peered. So that's kind of one way to do it, is to just utilize the backplane, and that would work even internationally too. So if you ever want, or if you want a cool thing to Google after this, go take a look at the undersea cable maps that each cloud platform has. I know Azure has a pretty diagram of all the different undersea cross connects that they have. AWS has the same thing, GCP, where they talk all about their multi-region support and their backplanes that they have. So usually, long way of answering the question, but usually your best bet is having those backplanes do the heavy lifting for the large amount of data. All right, got a question here from Max. Fully aware this is a tough question to answer. Oh, that's going to be fun. How would you see cost efficiency of a cloud-based workflow using Parsec versus a traditional post-production workflow in an office? Well, Max, the first thing that you're going to have to do is you're going to have to make sure that those VMs are scheduled. One of the things that if you've ever worked in the cloud, you know all too well, it's like sitting in the back of a taxi. The longer you sit in the back of that taxi, the more expensive it's going to get. Same deal in the cloud. The clock runs as soon as that instance starts. So when it comes to using a cloud-based workflow in a production capacity, you're going to want to use something like, I know in AWS, I think it's called the resource scheduler, allows you to set specific times that VMs turn on and off. You could say only run a VM from 8 a.m. to 8 p.m. every single day, with maybe the off case where somebody's in crunch and they need to run, or they need access to the VM after hours. Your best bet is to take advantage of the scheduling systems that are built in so that those VMs aren't running all the time. If they're running all the time, you're going to run into high resource utilization charges just because AWS or any cloud platform charges you for the time that the lights are on. All right, got another note here. So Azure doesn't want to provide NVV3, so NVV4 is a must. I'd be curious to know, is there a specific reason that you have to go with Radeon Instinct over a Tesla T4? I know for a fact that the Tesla T4 works. If you want to go with Radeon, that's great. We may want to follow up on that just to see. So I don't know for the webinar czars here, Avery and Zoe, if you can pull that together. Marketplace listing only shows V4. Thank you. Yep, we'll follow up with you.
All right, well, we're just about out of time. Thanks, Daniel, for answering everyone's questions. And thank you all for joining us today for our webinar. If you have questions that you think of later on, you can always reach out to us at sales@parsec.app. If you aren't currently a Parsec user and you want to try it out, we do have a consumer version that's free to use. And we also have a 14-day free trial for Parsec for Teams, one of our business solutions. So we've included the links to those here. And then lastly, we've also included the links to the AWS and Azure marketplaces if you're interested in checking that out as well. All right.
And for those that did have the more detailed questions on Azure and AWS, I do encourage you to reach out to sales@parsec.app, because that goes to myself as well as the entire sales team here at Parsec. And so we can definitely answer your questions.
Thank you.